Welcome to the BMT 2023 Calculus Tiebreaker. Today we take on an intriguing infinite sum. Compute the sum from n equals 0 to infinity of n cubed over n factorial. Let's break this down step by step. The key idea? We differentiate the power series of e to the power of x to extract the needed terms. First, recall the fundamental expansion. E to the power of x equals the sum from n equals 0 to infinity of x to the power of n over n factorial. Now let's differentiate this function to reveal a new pattern. The derivative of e to the power of x is still e to the power of x, which equals the sum from n equals 1 to infinity of n times x to the power of n minus 1 over n factorial. Multiplying by x shifts the indices, bringing us closer to our target. X times e to the power of x equals the sum from n equals 1 to infinity of n times x to the power of n over n factorial, which simplifies to the sum from n equals 0 to infinity of n times x to the power of n over n factorial. And after taking the derivative of both sides, we get e to the power of x plus x times e to the power of x equals the sum from n equals 1 to infinity of n squared times x to the power of n minus 1 over n factorial. After multiplying by x, taking the derivative again, and then multiplying by x once more, we get x e to the power of x plus 3x squared e to the power of x plus x cubed. E to the power of x equals the sum from n equals 0 to infinity of n cubed times x to the power of n divided by n factorial. Setting x equal to 1, we obtain the beautiful result. The sum from n equals 0 to infinity of n cubed over n factorial equals 5e. And there you have it. I've solved and published all SUMAC 2022-2023 solutions, something never done before. Whether you're preparing for advanced math programs or competitions, I offer personalized classes to take your skills to the next level. Reach out now to book your spot.